Welcome back as we continue our Terrell Spring 2015 Severe Weather Readiness Campaign. And for Monday, the topic is damaging thunderstorm winds and large hail. Now, uh, more often than not, obviously, get the tornadoes are the center of attention during severe weather and severe weather outbreaks. And so, therefore, it can be easily overlooked just how serious damaging winds and large hail can be. And so today's topic is all about the hail and the wind and the threats that they pose and the damage that they can do. So we have damaging thunderstorm winds. That's what we will start with. Um, First thing you need to know is that in order for thunderstorm winds to be considered severe, they must be at least in excess of 58 miles an hour or greater. So if it's anything below that, it may be gusty, there may be strong winds, but in order for them to be considered severe, must be 58 miles an hour or greater. And this right here is a picture of what can happen when you have damaging winds and uh, when they are at the severe level. As you can see, obviously, there is pretty heavy damage to the house. A tree has fallen into it, and obviously, if people were right in this area of the house, that could have seriously injured anybody who was there. And so, right there is a great example of how damaging winds can be uh, as dangerous as a tornado. So you have damaging wind downbursts. That's what we call basically an outpour of damaging winds, and you can get those from, thunderstorms, whether they're isolated in nature, whether it's a big squall line, what we call QCLS. There's a couple different types of downburst that we have, and one is called a microburst. This is a common situation during the summertime when we have single cell thunderstorms is what we call them. Basically, thunderstorms that rain themselves out. They develop because of the intense instability and moisture in the atmosphere. But if there's no wind shear to sustain the thunderstorm's updraft, they eventually just rain themselves out. And we'll talk a little more about wind shear in the next video because that has a lot to do with tornadoes. But basically, what you need to know is if there's little to no wind shear, the thunderstorm will basically build itself up, but if the wind shear is not there to sustain the updraft, it's basically just going to collapse. And doing so, it's going to produce an outpour of damaging winds. You have a lot of energy that gets basically pumped into that updraft, and then once it basically just explodes once it can't take it any longer, basically. And then that's when you get your microburst as the thunderstorm is raining itself out. They are usually very brief, sometimes no more than 5 to 10 minutes, but within that very brief time period, the winds can be extremely significant, sometimes greater than 90 miles an hour. Very significant winds, and sometimes they happen so quickly, they happen so quickly, and then they're gone so quickly that there's barely any time to get a warning out on those things. So sometimes they could just kind of develop at a moment's notice and be more of a surprise. Then you have a macroburst slash QCLS. Basically, that's basically when you have an outpour of damaging winds that last for a longer period of time and over an extended area. Extended swath of damaging winds that can occur over an extended area, obviously. And those tend to occur with big lines of thunderstorms. The technical term is QCLS, quasi-linear convective systems, but a lot of people just refer to them as squall lines. That's basically what they are. That means like a big line of thunderstorms. And sometimes squall lines can extend uh, hundreds of miles, and they can basically produce a swath of widespread, potentially significant wind damage. So that's kind of what separates a microburst from a macroburst. Basically, a microburst occurs from an isolated storm, usually very brief, usually occurs when a thunderstorm is raining itself out, basically collapsing. Macroburst is going to be uh, more, is going to last longer and over a larger area. And then uh, when a big squall line gets to be long enough, or basically when it lasts for a long period of time, when it has a span of over 240 miles an hour, then the squall line gets classified as a derecho, widespread damaging winds that can last for a span of at least 240 miles an hour or greater. A good example would be in June 2012, when we had a derecho. It actually kind of developed right over north central, east central Indiana, and it lasted all the way to Washington, D.C. Washington, D.C. Ended up killing about 13 people. That's a good example of a derecho, a big, long-lasting line of damaging winds, usually 70 miles an hour or greater, sometimes kind of pushing that 90, 100 mile an hour mark. So derechos can be very significant. They're pretty rare, but when they do occur, the result is often a large swath of intense straight line wind damage. Okay, so now we're going to talk a little bit more about what we call bow echo. This is basically a damaging wind signature that you can pick up on the radar. You may have heard of the TVS, the tornado vortex signature. This is a little bit different. This is a damaging wind signature. So I think a lot of us have a good understanding, or at least a basic understanding, of how radar works. These colors are obviously the precipitation within the thunderstorm. The brighter the colors, the more intense precipitation there is. So obviously, this is a line of thunderstorms that we have here, with a heavy rain, perhaps some occasional hail. But I want you to notice a feature with this little squall line here. Do you see how it kind of bows out, and it makes that kind of bow and arrow type configuration? We call that the bow echo. This occurs when the wind pushes, basically is strong enough to be pushing the precipitation at a rapid pace. So obviously when you have wind, the raindrops are going to be pushed forward. And so that's obviously going to reflect then on the radar data. So this precipitation is basically being pushed forward by the strong winds that are occurring with this line of storms. And so that is a very good indication that there is significant, potentially damaging winds within the thunderstorm, because we can see how far these precipitation echoes are being pushed forward. And so more than likely there is some very intense wind damage occurring with this line here in western Missouri. This occurred back in May of 2008, it appears. Alright. Hail, hail, hail. We all love hail. At least I do. So now switching gears a little bit, talking about hail. Hail must be at least 1 inch in diameter, quarter size, to be considered severe. And this would be a great example of that. We have hailstones being compared to a golf ball, so about right around golf ball size. Right around golf ball size hail with 2 very lovely hands to go along. So now let's talk a little bit about the production of large hail, and how hail works and how it develops. So basically, these thunderstorms, obviously, they have moisture to work with, right? The raindrops within a thunderstorm are basically pulled up into the updraft. That's a result of the moisture, obviously. It's basically the moisture inflow occurs with the thunderstorm, develops into rain. The rain is basically pulled up high into the updraft. And once it reaches a certain point, the raindrops freeze. At the higher you go, the colder the atmosphere is. In fact, it can get very cold up there real high in the atmosphere. Basically, it reaches a freezing level once it reaches a certain point. The updraft, typically the larger the updraft is, the more significant the hail threat is. That's why, if you remember in the last video, we talked about the updrafts of thunderstorms usually don't go very tall during the wintertime because of the lack of instability. That's why hail is typically not a huge problem during the wintertime with the wintertime severe weather setups. But instability, this is why instability, the surface heating that occurs from the sunlight, plays a vital role in large hail. This is why hail is a big problem in June and July and months like that. So the raindrops are basically tossed up here into the updraft, and the larger the updraft is, the larger the hail usually is. So the hail basically freezes. The rain basically freezes into ice, and these little ice stones are what we call hail, obviously. And so they basically circulate in the updraft until they get to the point where they are so heavy that the updraft is no longer able to sustain them. And then that's where they begin to fall. And like I said, typically the larger the updraft is, the larger the hail is. So the raindrops basically freeze up here into the higher levels of the atmosphere within the updraft of the storm, begin to circulate as they develop into ice crystals, and then they fall once they get too heavy and the thunderstorm is no longer able to support them, and that's how you get hail. And here is a wonderful example of what large hail can do to a beautiful home. And obviously we have seen the damage that can happen with hail on vehicles. So needless to say, hail can be a big deal, and so can damaging winds. They can both be deadly. The June 2012 derecho killed 13 people. That was the one we were just talking about. April 2001, there was a hailstorm that occurred in eastern Kansas and Missouri. It became the most costly hailstorm in U.S. history. And by the way, even though it is pretty rare, I have heard of hail-related fatalities before. So it's not always just the damage that's a factor with hail. And by the way, I believe this hailstorm, the most costly in U.S. history that occurred in Missouri, I believe the damage was like well over $2 billion. Bottom line, that's why you need to treat severe thunderstorm watches and warnings seriously, just like you would a tornado watch and a warning. And I know we get a lot of these. I know that they are very common. But the fact of the matter is, it's obvious that damaging winds and hail can cause a lot of problems for people. And they can cause a lot of damage, and they can kill. Derechos, if you think about it, talk about the derechos, like the one that occurred in 2012 from Indiana all the way to Washington, D.C., that damage was far more widespread than any tornado, obviously. It may not be intense, of course. It may not be as intense of a stronger, larger tornado, but the winds of a derecho can reach the strength of weak tornadoes. So imagine basically like a weak tornado, the damage of a weak tornado for over a path of 200 to 300 miles. That's, needless to say, a lot of damage. So the bottom line here is to take the severe thunderstorm warning seriously. Large hail and damaging winds can be a major problem, and they can result in fatalities and significant damage. And that is where we will stop.